Alright, graphs that have an x in the exponent are called exponential functions. What I like to think about, if you have a highlighter or you can just underline it, is that if there's an x in the exponent, as in there, it is an exponential function. You eventually have to decide whether it's an exponential or logarithm. And this is how we can tell if it's exponential. Okay, there's an x in the exponent. That's your hint for logarithm, or for exponentials. Alright, exponential functions have a horizontal asymptote. Have a horizontal asymptote. Alright, you guys see this letter B that's attached to that exponent? Okay, so whatever number is attached to our exponent, that's what we're talking about right now. If that number, which we just call B, if it is greater than 1, it is going away from the asymptote, and we call that a growth. You will have to memorize this part. And if B is smaller than 1, that's what that means. If B is smaller than 1, and the graph is going towards the asymptote, we call that a decay. Alright, I want you guys to think about it like this, or I'll show you how I think about it. These words here, away and towards. My graph is going away from the asymptote. I think about the word grow because I'm looking at the W, the four-letter word. Kind of try to, make up things in my head that kind of make sense. Away reminds me of grow, which tells me it will be a growth. And then the word towards, which means that my graph is going towards the asymptote. I think about decay because the word towards has a D in it, and decay starts with a D. So in my head, I just remember that. The more we do it, the more you'll catch on to it because it's really, really, really important. You guys have to memorize these things right here. Let's take a look at number 1. All right, we have y equals 2 to the power of x. So grab your calculators. Go to y equals. All right, let's type in 2 to the power of x. If you have one of the newer calculators that is like, I don't think one has one in there. If you have one of the newer ones that's kind of like flat, can't really describe it, but they're the ones that you have to charge. You know what I'm talking about? They're different colors. If you have those, that's what this one looks like. You don't have to put your exponent in parentheses, it just kind of picks up on it. The ones that you guys have, you have to put your exponent in parentheses. Right now it's just an x, so we're fine. It doesn't really matter if that's in parentheses or not, but if you have like an actual number or something longer than that, you have to put it in. So we'll get there in a little bit. Alright, so graph it, take a look, make sure that yours looks just like mine. If it doesn't for any reason, raise your hand, because sometimes your calculators are set differently. Everyone's confusing me. Alright, judging from this, I can tell that my asymptote, my horizontal asymptote is 0. In a little bit, we'll be able to tell how we can figure that out from our equation. But for now, my asymptote is 0. So let's go and get some points. Go to your table. I'm not really picky on the points, but you do need at least like 4, at most 5. These are pretty easy points. Like I'm going to start with -1 and I'll go down to 3. So let's go ahead and write some points in. I have -1, 0, 1, 2, 3. What do you guys get for your y value for -1? What does it say? 1 0.5. All right, what about 0? 1, about 1? 2, 2?
4.
What'd you say?
4.
4. And then 3?
8.
All right, good. All right, so since those are my asymptotes, or sorry, those are my points, I'm going to go ahead and I'm going to draw a dotted line where my horizontal asymptote is. So at the 0, when y is 0, I'm drawing a dotted line. Whenever I draw this dotted line, you guys have to draw the dotted line. And then just plot your points. You have negative 1.5, so that's kind of like right there in the middle. 0, 1, 1, 2, 2, 4, and 3, 8. All right, those are my points. Your points won't be perfect, especially if there's decimals. But if it's 0.5, I would just estimate like this in between those two numbers. Once you have your points, connect them as best you can. And remember, you're not crossing the asymptote. So you get really, really close to the asymptote, but you don't touch it. Right, everyone plot theirs already? James, you still plotting? Alright, everyone take a look at this. When we're trying to figure out growth or decay, you always start from the left. So let's start here. Look at my pinpoint. Am I going away or towards my asymptote? Did I go away from it or towards it? I went away, right? You guys see that? I'm here. My asymptote is there, the dotted line. I'm going away from it. So would that be a growth or decay? It would be a growth. Good. Because I think about my away, the W, growth has a W. So that would be a growth. That is a question you guys will answer over and over and over. So please make sure you're understanding that. If you don't, you can ask questions. All right, that was number 1. Let's go to number 2. Also, before we go to number 2, if I did not know how to find my growth and decay based on drawing on the picture, I can look at my original equation. If that number that is attached to my exponent, if it is bigger than 1, then it grows. So is 2 bigger than 1? Yeah, so it's a growth. But if you look at the second problem, I can tell I have 1/3. So that is smaller than 1 is going to decay. Okay, but we'll get there in a little bit. Got your calculators, type this in. Clear everything out. You have 1/3 to the power of x. In this case, once again, you just have an x by itself, so you don't have to put it in parentheses. I'm going to graph it to see what it looks like. Once again, I'm going to tell my asymptote is going to be 0. Let's get some points. Alright, some of these points aren't like perfect, but let's start at -2. Try to get as many nice points as we can. Alright, -2, what do you guys get for your y value? 9, about -1. 3, 0. 1. 1. Is that the point for repeating?
Yeah.
And just show it like that, and then 2. You should have 0.1 repeating. Anything that's a decimal, you're just going to estimate. I'm going to draw my horizontal asymptote at 0. And then I'm going to plot my points. I'm starting at the origin. I'm going from -2 to 9. So 1, 2, 9, -1, 3, 0, 1, 1.3. For 1.3, I'm just going to try to get really close to that 0. Doesn't have to be perfect. And I'm going to try to miss a couple points, but try to connect all your dots. It does not have to be exact. Try your best. All right, Anthony, if I go from left to right, am I going away from the asymptote or towards it? What did you say? So would that be growth or decay? Good. Are we all going number 2? All right, number 3. Look at the graph and decide whether there's growth or decay. Well, on number 3, I always go left to right. If you don't go left to right, then your answer is going to be opposite. Let me see that shit. From left to right, am I going away or towards my asymptote? Away. Which one would that be? Growth. All right, on example 4, I'm going from left to right, and I'm going away or towards it. Towards, so that would be decay. You will have this on your quiz for class. Okay, turn the page. We've done this before. We've just never really applied it to exponential functions. But hopefully it rings a bell. Okay, so this is about transformations, and we want to know, what does each thing tell me to do? Let's take a look at my A. That A means just that number that's in the very front, not the number that's attached to my exponent, but the number that's out front. My A can tell me 3 things. What does it tell me if that first number is negative? Yes, good. We flip or we reflect. You can write either word. Whether flip or reflect, that first number is a negative. What if that first number is bigger than 1? Starts with an S. Yeah, stretch. Good. If that first number is bigger than 1, we stretch. And if that first number is smaller than 1, we are going to compress. The part that's new that we really haven't talked about is the letter B. Okay, that's the number that's attached to your exponent. We briefly just talked about this, but if that letter B is bigger than 1, are we going to grow or decay? Yep, we're going to have a growth because it is bigger than 1. Think about increasing or growing. And so if it is smaller than 1, you're going to decay. Alright, my H here. We're used to seeing the H in a parentheses or like an absolute value signs. It can tell us which way to go horizontally. So if I have a negative H, what do you guys think I'm going to do? Go to the right. And if I have a positive, I go left. I like to think of this as plus sign, and there's 2 plus signs in the word left. That's just kind of my way of thinking on that. plus k can tell me two things vertically. If it's a negative, which way do I go? Going down. And if it's positive, going up. All right, this part is very important. Your horizontal asymptote. All right, your horizontal asymptote, y is equal to k. What that means is this very last number here tells me what my horizontal asymptote is. That is very important. You have to know that. Your last number tells you your asymptote. What if there's nothing there? What's my asymptote? What'd you say? Yeah. There's nothing there. We can assume they meant to put plus 0. And so my asymptote will be 0. For these problems, your domain will always be negative infinity to positive infinity, because my graph is going to keep going from left to right. It may not look like it, but it is continuously going. The part here that's new is your range. Your range is going to go from your asymptote to positive infinity, or you're going to write negative infinity to your asymptote. And for your range, we're still going from bottom to top. Make sure you guys have this exactly what I wrote. You should be ready. Any questions here? All right. Okay, so let's take a look at this. Before we get started with anything, do I have a number after my exponent? Do you guys see anything here? No, so that could really mean plus 0, right? So my horizontal asymptote is going to be what? 0. Good. If there's no number after your exponent, then you assume your horizontal asymptote is just 0. All right, so grab your calculators and let's type this in. Make sure that you type this in exactly how I type it in. Christina, for this one, I want you to think it. Can you put your 4 and your 2 in parentheses and your exponent? Okay. Everyone else do it this way. Let's write 4 times 2. Christina, you're going to put both of those in their own separate parentheses. And then to the power of parentheses x minus 3. The important part here is that everyone has to put your exponent in parentheses. And then hit graph. Make sure you have what I have. No, it doesn't. Okay, so for these problems, and your y equals, if it says like 4 times 2, just write it 4 times 2. If you put the 4 and the 2 in parentheses, it's going to throw your answer off. The only thing you guys have to put in parentheses is the exponent. Does that make sense? Okay. So you guys should have this graph. Let's go to my table. Let's see here. I started with 0. So let's break down these points. For my points here, I have 0.5, 1, 1, 2, 2, 3, 4, and 4, 8. Because I know my asymptote now is going to be 0, I'm drawing a horizontal line right at 0. Once we keep going with this, you guys will have to realize whether we have a horizontal asymptote or a vertical asymptote. So make sure you remember exponentials always have a horizontal asymptote. And then go ahead and plot these points. 0.5, 1, 1, 2, 2, 3, 4, and 4, 8. And then try to connect as best you can. All right, Deshaun, take a look at this. Am I going away or towards my asymptote? Away, so that would be a growth or decay. Yep. Alright, my domain is always going to be negative infinity to positive infinity. My graph keeps going from left to right, on and on and on. Alright, my range. If I start from the bottom, my graph starts at my asymptote, which is what? 0. It goes up all the way to infinity. So my asymptote is from 0 to infinity. So it's your asymptote to infinity or negative infinity to your asymptote. Your y-intercept, that is not changing. We can find our y-intercept two ways. You're looking to see where it crosses the y-axis, which is there, or just looking at your calculator to see where x is 0. Wherever x is 0 is your y-intercept. So we have 0 and then 0.5. So you can write 0.5, or you can write y equals 0.5. Either way, or either answer works. All good on number 5? All right, look at number 6. Let's go ahead and type this in. Look at your y equals, clear it out. I have 2 to the power. I'm going to put in parentheses x plus 2. I'm going to scroll over, you don't have to, and then plus 3. Take a look at it, make sure that your graph looks like 5. Good. Mm-hmm. This one here, good. Okay, if your graph looks like mine, go to your table. I'm going to write down some points. I did -3 and 3.5, -2 and 4, -1 and 5, 0 and 7. You can write 1 if you'd like, you don't have to. Alright, the first thing I'm going to do is I'm going to look for my asymptote. The number after my exponent is what? +3. So my horizontal asymptote is +3. I'm going to go to y is +3 and draw my dotted line. That's my asymptote. plot my points. You guys can go ahead and do that. What that looks like. All right, James, from left to right, am I going away or towards my asymptote? You're going away, but that'd be broken to 10. Good. Kenzie, what's my domain? Negative infinity to positive infinity. Christina, let's do the range. From down to up, where's my graph starting? Yep. So your asymptote is 3, and you're going up to where? Positive infinity. And Anthony, for your y-intercept, where are you crossing the y-axis? Not quite. What's this point here? 0, 7. Yep. So you're looking for where you're crossing this y-axis, which is at 0, 7, or looking at your calculator for where x is 0. So your y-intercept is 0, 7. Or you could write y is 7. All good? All right, let's look at your transformations. If you look at this original y equals 2 to the power of x, and then the new one, I have some things that are missing from the first one. All right, my minus 2 is new. What else is new? The plus 4. So I have 2 transformations. All right, that plus or that minus 2 tells me to do what? Do I go left or right? Right 2. You guys can look back at your transformation notes if you need to. Okay, but whatever's with your exponent is telling you left or right. And what is that plus 4 telling me? Up 4. My K always tells me whether I go up or down. All right, and number 8, we're going from 3/4 to the power of x to negative 3/4 to the power of x plus 1 minus 2. What parts are new in my second part? Plus 1, the minus 2, what else is new? There's one more thing. The negative, right? Alright, so I have 3 transformations here. Because he already said I want to flip. So we reflect. The plus 1 tells me to do what? Left 1. And the minus 2? Down 2. If you struggle with your transformations, you just have to study this. You have to study what does the negative mean, what does the plus 1 or minus 1 with the exponent mean, what does the last number mean. All right, any questions there? All right, so this part here, we're going to introduce, but not really talk too much about until next class. All right. E is an irrational number. An irrational number which is approximately 2.718. You'll eventually have to know that. Today you don't really have to know it per se. On your calculator, the way that we get an E is by hitting your second key and then your LN. Your LN is right next to your 4. Okay? So let's take a look at number 9. We have e to the power of x. Believe it or not, those two letters will give us numbers. So clear it out. To type in e, it is not just typing in one of these random letter e's, not the same. You need to hit second and LN, that's right beside the 4. And that e comes up. And then you have your power of x. So e to the power of x. Let's graph it. And yours should look like mine. By typing in that e, it's kind of like pi, how pi just keeps going on and on and on and on and on. That e also keeps going on. You just type it in, so it's gonna, if you type in that 2.718, it's gonna give us a rounded answer, which is a little different. So I'm gonna get a table. Do I have points here? Yeah. I started with -1, so you guys can write down the points that I have. I have -1 and 0.37, 0 and 1, 1 and 2.7, and then 2, 7.4. Same thing applies to my asymptote. There's nothing after my exponent, so I can assume it is what? It is 0. That's understood. We don't have to write that in. So my horizontal asymptote is 0. Put your dotted line right there. Someone asked earlier how important writing your asymptote is. It's more important than your points. Okay? If you at least put your asymptote and you kind of sketch what the graph looks like, that's better than just getting the exact points and not having an asymptote. So make sure you always have that. Alright, so -1, 137, 1, 0, 1, 2.7, so 1, 2, almost at 3, and then 2, 7.4. I don't know. Once you have your points, sketch your graph. Christina, growth or decay? It is a growth because it is going away from my asymptote. All right, my domain. Anybody? Negative infinity to positive infinity. My range, from down to up, my graph starts at the asymptote, which is 0, and I'm going all the way up to positive infinity. My y-intercept, I'm looking to where my x is 0, my table, and I have 0, 1. We're going to do this last one together before you guys go on your own. Before we get started, what's my horizontal asymptote here? What'd you say? -3. I know that because it is my number after my exponent. So y equals -3. Alright, you type this in, you would get -3 and -2.9, -2 and -2.7, -1 and -2.3, and 0 and -1. draw my asymptote at -3.
Gotta be some big piece of equipment out there.
This thing is so close to this.
Yeah, it's like
Alright, there's my asymptote. I'll plot my points. -3, -2.9. -2, -2.7, -1, 2, 3, 0, -1. Your graph should look something like that. Let's be a growth or decay. Okay, growth because we're going away from the asymptote. My domain is going to be negative infinity, positive infinity. My range is a little different. Down to up, my graph starts at -3 and I go up to positive infinity. My y-intercept, I'm looking at my table where x is 0. We have 0, -1. All right, I have one more thing to do with you guys before you do your classwork. Look at number 11. This is more so what you'll see on your quiz. Okay, the ones we just were doing are a little bit easier. So let's go to your y equals so we can all type this in. I want you to type in exactly what you see, okay? Exactly what they have. So you have -2, parentheses 2. So -2 times 2. Don't make that -4. And then parentheses. I'm going to type in x plus 1 in parentheses. I'm going to type in x plus 1 in parentheses, and then -3. Graph yours and make sure it looks just like mine. If not, raise your hand. Can I help you? Is everyone good with this one? All right, good. So when you go to your table to get some points, you'll get -3, -3.5, -2, -4, -1, -5, 0, -7. Those are the points I got. Look at my equation, your function. What is your horizontal asymptote going to be? Nope. -3. Looking at that last number after my exponents. Okay, so I'm going to draw a dotted line at -3. And then I'm going to go ahead and plot some points. 1, 2, 3. So this one's going to be below the asymptote. This is a little different. We have -2, -4, -1, -5, and 0, -7. That's what your graph should look like. You will get points for doing your graph too. And if you don't feel like drawing it again, well then you're just going to forfeit that point. But it could be an easy point for you or not a point at all. Alright, from left to right, like a growth or a decay. Am I going away or towards it? Yeah, I'm going away, so it is a growth. My domain is going to be what? Negative infinity to positive infinity. Alright, my range. Pay attention to this part. From down to up, I'm starting from where? There's an arrow here, so I'm starting from negative infinity, I'm going up to negative 3. So my range is from negative infinity to my asymptote, which is negative 3. My y-intercept is going to be what? Yep, so you have 0, negative 7, or you can write y equals negative 7. You cannot just write a number. You have to either write the coordinate point or you have to write the y equals. You can't just write negative 7. All right, increasing and decreasing intervals. From left to right as well. From left to right, am I increasing or decreasing? You're decreasing the whole entire time, right? I'm always decreasing. So am I increasing at all? No. So that's going to be none. You're not increasing at all. For these two problems, for this unit, you will either have none or you will have all row numbers. So for decreasing interval, I'm decreasing the entire time, so that's my all row numbers. Negative infinity to positive. I'm decreasing from left to right the entire time. It's not from going up a little bit and back down or any of that. Erase this. Alright, if you guys take a look at your end behavior, okay, this is as x approaches negative infinity, so this is your left, and this is as x approaches positive infinity, which is your right. Take a look at what your arrow is doing. This left arrow is getting closer and closer to my asymptote, so therefore, as x approaches negative infinity, my answer is going to be negative 3. Because this left arrow here is just getting closer and closer to my asymptote. This right arrow here is getting closer and closer to what? What am I going towards? Negative infinity. For these answers, one will be going towards negative or positive infinity, the other will be going towards your asymptote. Okay, so I want you guys to do 12 and 13, and then we'll go over the answers. Take about, I don't know, 8 minutes. You can check yours with mine. I'll also put the points that I used. You are not required to write your points down. Number 12, is your graph above the asymptote? Okay. So ignore my first. one? Alright, check your answers with mine. Anything look weird that you didn't get? For this one? Because you're in behaviors, this is your left one and this is your right one. This one's just going up to infinity. This one's going to keep getting closer and closer to your asymptote but not touch it. So it's going towards your asymptote. So for these problems, this unit, on your in behavior, one's going to go towards positive or negative infinity and one's going to go towards your asymptote. All right, number 13. These are a lot of negatives, so that's it. The cleanest point here was 0, -1. I plotted that and I sketched my graph. You can do that as well. You don't have to actually list all your points. Behavior here at the bottom. Okay. All right, good.